a lot of details in causal inference depend on control of the experiment. There are other approaches which don't have to be associated with that, but a lot is about controlling certain aspects of the data. One such aspect is confounding. So just to relate to what I was saying previously about correlations, most correlations in observational data come from confounding, or some third variables which are not adjusted for or not accounted for initially. They could cause many variables to be correlated but not causally related. And there is the problem of confounding, one of the most important problems in causal inference. Obviously, clinical trials are designed to be very rigorous and to have specific methodologies implemented to deal with confounders and to isolate the experiment, isolate the variables in the experiment. In phase 3 controlled trials, this is very rigorous, and that's why many would say that phase 3 controlled trials are the gold standard of life science research. But the reasons behind this are really in the causal inference. Phase 3 controlled trials are 99% designed for causal inference. One of those aspects was exactly what Justin was mentioning, which is the counterfactual design. So we usually have control groups. It could be standard of care groups, placebo receiving groups. So those groups are used to control for that counterfactual aspect. And then we have intervention, exactly as Justin said. We have control, we have intervention, and that's what makes one of the principles needed for causal inference. Another principle, which is very important, is the randomization. Randomization is probably one of the most important segments of phase 3 clinical trials. Many think that randomization is there just for removing the selection bias. This is totally wrong. This is a very superficial interpretation. Randomization is there to correct for many types of bias. It's there to correct for bias originating from known variables, but very importantly, randomization is there to correct also for unknown confounders, for potential latent variables. And this is why randomization can isolate the variables that we're interested in. In phase 3 clinical trials, it's usually we have a control group and we have the intervention, we have the treatment. So we want to see what is the outcome of this treatment. Does a specific treatment or drug X work better than standard of care in certain population? So to do that, we need causal inference. We need to isolate the effects of the confounders as much as possible. So counterfactual design, randomization combined, they are the core of causal inference in randomized phase 3 controlled trials. There are other details which are very important, such as time to event data, right? Time is another very important aspect in causal inference. We know that causality is time related, and that evaluating time aspect in a study is also very important. We'll discuss about this in more details later. For now, I will just introduce these topics and maybe say a few words of when would one need a different approach. So this was an approach where one can actually perform, a research company or institution can actually perform a randomized controlled trial. What happens when randomized controlled trial is not feasible? Frequently, randomized controlled trials are very expensive. They take a lot of time, and sometimes they're not even feasible for ethical reasons. So there is a huge amount of data that is generated in non-experimental scenarios, in scenarios of generating real-world evidence from hospitals where treatments are occurring in a non-simulated, non-experimental environment. Actually, majority of biomedical data is from this field. So statisticians have developed various approaches to deal with that situation when we cannot randomize the data, we cannot get fully controlled experiment. So we use different approaches, such as propensity score matching, calculating inverse probability weights, using special variables, which are very important, instrumental variables, but all this requires both statistical and domain knowledge. That's why I said causal inference is not easy. A lot of experts in this field need to have a multidisciplinary knowledge, especially domain knowledge of the topic that is being studied. So